Hi, welcome to Demystifying Math. Today we're going to be working on improper integrals that involve transformations. For this problem we're going to be trying to find the area from 2 to infinity of the function 1 over x squared. We can do this pretty easily by rewriting the integral as a limit as b goes to infinity and then using 2 and b as the endpoints of integration. Plugging in 2 and b after we integrate normally, we end up with 1/2. Well, we got 1/2 because we know that the limit as b goes to infinity of negative 1 over b is just 0. So we're only left with 1/2. So we would say that the area under the curve of 1 over x squared from 2 to infinity converges to 1/2. Okay, based on what we just learned, what do we know about the area of that similar region for any stretches or shrinks of the graph? If we multiply the graph by a constant, would that graph's area also converge? Let's take a look at an example. We have the integral from 2 to infinity of 3 over x squared. So what we're doing is multiplying our graph by 3 or stretching it by a factor of 3. Let's go ahead and integrate as we normally would. So we have negative 3 over x, and we're going to take the limit as b goes to infinity and use 2 and b as our endpoints of integration. By plugging in, we ended up with 3/2. Well, we know that the limit as b goes to infinity of negative 3 over b is just 0. So it is 3/2. And what you should notice is that 3/2 is really 3 times 1/2, 1/2 being the area that we got for the original graph of 1 over x squared. So what we've done by multiplying the function by 3, we've also multiplied the area by 3. Alright, so what would happen if instead we multiplied the function by 1/3? Well, we're shrinking the area when we're doing that. We're also causing a shrink to the graph, meaning the graph is closer to the x-axis. You can probably guess what the answer is going to be, because in this case we have 1/3 of the original area. 1/3 of 1/2 gives us 1/6. So analyzing the function by taking the integral is going to give us that 1/6 that we expected to get. So basically what happens is every time that you multiply a function by a constant, it's going to converge if the original function converged. It will diverge if the original function diverged. Let's look at this particular problem of 1 over x squared. We're multiplying it by a. Well, we can always factor out the a outside the limit. And that just means that we're going to end up with a times the original area. So whether you're multiplying by 1/3, shrinking the area, or multiplying by 3 to stretch the area, you're going to get a convergent function if the original function was convergent. Okay, so our next part, what about vertical translations? Will the graph still converge if we shift it up? Well, in this case, we've taken our 1 over x squared and we shifted it up by 1. Which means that the graph is heading toward 1 instead of heading toward 0, which causes us to have a whole lot of area below the line y equals 1. If we take that area and break it up into small regions, what you'll see is that you have each one of these rectangles has an area of 2 square units. 2 square units. And we keep adding 2 plus 2 plus 2, we're going to go out to infinity. We do have an additional area above the line y equals 1, and that little bit of area is going to shrink and get smaller and smaller, but we still have these large areas that are going to be added together. And we can see that when we take this integral. We still have b here. As b goes to infinity, this number is going to go to infinity. It doesn't really matter what everything else is doing because this is causing it to diverge. The negative 1 over b is going to 0. And the 1/2 and 2 just stay that way. So in this case, because we shifted the graph up, we caused it to become a divergent area going to infinity. Okay, what about horizontal translations? Will the graph still converge if we shift it to the right? So we took this graph and we shifted it 1 to the right. Let's go ahead and analyze it by looking at the integral. So we're going to take the limit as b goes to infinity from 2 to b, integrate as we normally do, and then plug in 2 and b into our integration there. So we ended up with 1. So So we do have a little bit more area by shifting it to the right, but it still converges to a specific number. And that's going to happen anytime that you shift a graph to the right. It's still going to be convergent if the original function is convergent. Okay, I hope this helps you a little bit with improper integrals. And thank you for joining us at Demystifying Math.